Okay, this is the last example in the section on polar coordinates. And so they want us to find theta dot and theta double dot when theta equals 180 degrees. And we're given the total velocity magnitude at 4 feet per second, the acceleration magnitude at 30 feet per second squared. And we're given an equation of r in terms of theta. And this is a cardioid equation. It looks kind of like a heart if you look at the dotted line there. This looks like it's going to be painful. I can see the strategy is we're going to get a v, which is a function of r's and thetas, theta dots, an acceleration, which is going to have r dots, r double dots, theta dot, and theta double dots. And we're going to do Pythagoras theorem, set the whole thing equal to 4, and hopefully we can back out what theta dot and theta double dot are. So let's get started. So again, we know the velocity in polar coordinates is r dot in the r direction, okay, and r theta dot in the theta direction. And we know that the magnitude of the velocity is 4 feet per second, and that's going to equal to the square root of r dot squared plus r theta dot all squared square root. And I'm going to make this a little simpler by squaring both sides. So we know that 16 is going to equal r dot squared plus r theta dot all squared. And so we're just going to put in r and r dot and see if we can solve for theta dot. Okay, so we're going to need the equation for r dot. So taking the derivative of the expression for r, 0.5, the derivative of minus cosine is sine theta, and then using the chain rule, we have to add in a theta dot there. And I'm going to write the equation for r here. It was 0.51 minus cosine theta. And so it says that theta is 180 degrees. Okay. So cosine of 180 degrees is minus 1, and sine of 180 degrees is 0. So we know that r dot, interestingly, is going to be 0, and r is going to be 0.5 times 1 minus 1, so plus 1. The radius will actually be 1. So putting this into our equation of 16 equals r dot squared plus r squared theta dot squared. We're going to get 16 equals 0. That's nice. Plus r squared, which is 1. That's also nice. Theta dot squared, oh, that's not that bad. Theta dot equals 4 radians per second. So we're obviously going to need the acceleration equation to get theta double dot. So let me write that out. The acceleration, remember, in the radial direction is r double dot outwards. The linear acceleration minus the centripetal acceleration, r theta dot squared. That's in the radial direction. And in the tangential direction, r theta double dot. So we're going to solve for that right there. Plus the Coriolis r2 r dot theta dot, again, all in the tangential direction or transverse direction. So let's recap everything we know. We know that theta dot is 4 radians per second. We just got that. We know that r dot is going to be 0. We know that r is 1. And so the last thing we're going to have to figure out here is r double dot. So let's do that next. So previously we found out that r dot, the function, is 0.5 sine theta theta dot. So it's not going to be too bad, I hope. So r double dot is 0.5. Derivative of sine is minus cosine. And by the chain rule, you have to throw in a theta dot times theta dot. and plus 0.5 sine theta times theta double dot. So, you know, I'm just using the product rule where that's F, that's G, that's the derivative of F, and that was the derivative of G. Okay, so there we go. Let me highlight all the F and G parts. Okay, so all we have to do now is evaluate this when theta is 180, and when theta is 180, cosine is -1, sine is 0, so that's nice. That makes this equal to 0.5 theta dot squared. Okay, so putting everything in, we get A equals 0.5 theta dot squared minus R, which is 1, times theta dot squared in the R direction, plus R, which is 1, times theta double dot, plus 2 R dot theta dot, but R dot at theta equals 180 was 0. And we know also that theta dot was 4. So we get plus 0.5 times 16 minus 16 in the radial, plus theta double dot in the tangential. Simplifying that a little further, we get minus 8 in the radial plus theta double dot in the transverse. Okay, we are also given way up at the top that the total acceleration at this point in time is 30 feet per second squared. So we know that that equals the square root of 8 squared plus theta double dot squared is going to equal 30. So 8 squared plus theta double dot squared equals 900. And solving for theta double dot, we get the wrong answer. And so I went back and looked for my mistake, and my mistake, maybe you saw it, was right here. The derivative of sine is not minus cosine. The derivative of sine is just cosine. And so when you put in the cosine of theta is -1, R double dot is minus 0.5 theta dot squared. So we have minus 0.5 theta dot squared in this acceleration equation. And so we have minus 0.5 times 16 minus 16, which makes this minus 24, not minus 8. And so we get 24 squared plus theta double dot squared, 24 squared. And now we get theta double dot is exactly 18 radians per second squared. Somebody thought very hard to make all the numbers come out perfect like that. Okay, that's this problem.